With that, let us segue into the panel on technological pathways for Harbourcraft. This panel will focus on the net zero pathways and designs for different Harbourcraft types, explore the feasibility of engines running on future fuels, and discuss how to make clean Harbourcrafts more economically viable. This session's moderator is Mr. Ng Bing Rong, Director for Decarbonization Planning and Infrastructure at MPA. Mr. Ng, please. Joining Mr. Ng on the panel are the following distinguished speakers. May I invite them to join us on stage as well. Mr. Alex Meyer, Director for Marine O&G Segment APAC at Cummins. Mr. Nikhil Garg, Managing Director for APAC at TICO 2030. Mr. Tan Tai Yong, Managing Director for Strategic Projects and Technology at Kwok Maritime Group. Mr. Ko Shu Yong, Director for Global Sustainability at the American Bureau of Shipping. And Mr. Svein Erik Oerstad, Head of Business Development and Sales at Amaji, Singapore. To post your questions to the panelists, please use the QR codes on the screens behind me. Mr. Ng, may I hand over the floor to you, please?
Thanks, Lian. Very good afternoon to everyone. This is panel 4. I know this is just after lunch, so hopefully we can get this discussion a bit more exciting. Of course, we're looking at the technology side of things, and hopefully it's not too dry. But we have a panel which has a wealth of experience, and I'm very sure that we'll be having a very engaged discussion over the next 45 minutes or so. Well, to start, I mean, earlier on this morning, when CMPA actually ran through all the plans and initiatives that we're looking at, a large part was looking at the Harbourcraft sector and what we have been doing over the past year to actually encourage the industry to decarbonize this sector, which is typically a rather hard to debate sector, right? And a fair bit of focus has been on electrification. This certainly is something that is quite feasible, especially for the smaller craft. But we also recognize that there are other types of craft, for example, tugs or bunker tankers, where the power demand might be a bit higher or the endurance requirement might be a bit more, that electrification may not be necessarily the only pathway that is workable. So over the next 40 minutes, we'll try to discuss a bit more on what other pathway that actually the industry can actually study into or focus on to look at how to decarbonize the Harbourcraft sector, right? So to start off, I think we'll invite each of the panelists to give a short introduction of themselves and what they do, maybe about 1 minute or so. Yeah. Starting from Alex.
Thank you very much. My name is Alex Meyer. Good afternoon to everybody. I am the head of our oil and gas marine sales in Asia Pacific for Cummins Inc. We're one of the larger independent engine manufacturers in the world, and Asia Pacific is one of our biggest markets.
And Nikhil?
Good afternoon, everyone. My name is Nikhil Garg. I'm the Managing Director of TICO 2030 for the Asia Pacific region. So TICO 2030 is a Norwegian company that manufactures hydrogen PEM fuel cell stacks and fuel cell modules for the maritime industry. We are building a gigafactory in Norway where we'll be producing 3.2 gigawatt of fuel cells by 2030, and that's mainly for the maritime industry. Thank you.
A very good afternoon to members and friends of the maritime industry. My name is Tai Yong Tan. As the MD for Strategic Projects and Technology in the Kwok Maritime Group, I support my colleagues in the two technical fleets from PCL and Porsche, as well as the Center of Excellence for R&D in the Kwok Maritime Group, besides running the CSA. Thank you.
Hi, good afternoon, everyone. My name is Shu Yong. I'm currently the director for the Global Sustainability Center in ABS Singapore. Basically, ABS has 5 global sustainability centers globally. So there's Copenhagen, Houston, Athens, Shanghai, and Singapore. So Shanghai, I happen to be in Singapore, which we covered APEC and also Middle East and India. So what do we do within the Global Sustainability Center itself is we support our clients in whole value chain in regards to decarbonization strategy, as well as to how to actually goes into fleet renewal and what are the alternative fuels that is actually moving forward. And of course, electrification is part of it with this era of play, in this shipping era. So that's basically how we support my colleagues also within the engineering and also the operation side. Thank you.
Good afternoon, everyone. My name is Svein Erik Øyestad. I'm the head of business development for Amogy Singapore. Amogy is still technically a startup that is focusing on ammonia cracking and combining this with a fuel cell solution. So essentially utilizing ammonia as a fuel, but instead of combusting it, we utilize it with a fuel cell to generate electricity straight away without any emissions or any sort of other byproducts aside from what comes from the fuel cell itself. Thank you.
All right. Thank you, panelists. Well, being the moderator, I had the privilege to ask a few questions first to kickstart. Maybe I'll start my first question to Taeyong, just wondering. Well, the proposal by Coastal Sustainability Alliance, which you were heading previously, all right, and is led by Quad Maritime Group, it was shortlisted by MPA to go through a targeted program to enhance the design. And with that design enhancements, and hopefully with the demand aggregation of your PXO EXL1 cargo lighter, what is the next steps for CSA to support the decarbonization of the logistics industry, where larger hovercraft such as tugboats and tankers with higher power demands are concerned?
Thank you for the question. The Coastal Sustainability Alliance have grown since we launched it in March 2022. From 7 founding members, today we have 27. So beside the coastal supply vessel, we are looking at electrical tugboats. And this PXO fully electric e-tugs will be targeted for deployment in 2025 for operation within the port limits. What sets us different is because Pacific Workboats is part of the CSA, a subsidiary in Quad Maritime Group. So we are able to gather all the data and information from their operation in the tugboats for the last few years. So with that, we design the tugboat so that it's capable of operating at business as usual. And using the electricity from the grid, this new electric tugs will be able to reduce the CO2 emission by at least 30% and meets MPA 2030 requirements by going full electric. I think this electric tug goes beyond having an energy efficient ship with the right energy storage capacity. 2 of the CSA members, Marina Offshore and Pacific Workboat, they are currently working on an operational model so that we can optimize the demand and supply matching collectively to position their tugs strategically to reduce dead mileage. Besides that, our technical members are also developing new products and infrastructure, and they are committed to invest and develop their products for the methanol and ammonia fuels and their respective bunker vessels. I can think of other examples like the production of B50 brand, biofuel brands, and the co-design of battery energy storage systems. By 2030, we hope that together with the charging infrastructure and the just-in-time operation by Jurong Port and MPA, our hybrid and fully electric PXO fleet will support the decarbonization for tugboats and bunker tankers. We recognize that IMO and MPA has set clear sight and support for the multi-fuel bunkering transition. So the PXO E-Tug has been designed and approved in principle by class for future retrofit for use in the net zero fuel, including dedicated space for storage and fuel preparation on board. This will ensure that the e-vessel built today will have ready option to extend its endurance, as the current energy density of battery are not ideal as compared to green fuel if they are commercially viable and available in the near future. Thank you.
Thanks, Taeyong. I mean, very heartening to hear a lot of things that Quad Maritime Group and the Coastal Sustainability Alliance is working on, helping to decarbonize the fleet. Over to Alex, actually. I mean, besides the electrification path, there's of course alternative fuels, like for example, methanol and ammonia-like. And right now, I think quite a fair bit of focus is on the for internal combustion engines for all these fuels. Will soon become a reality for the larger engines that will power the ocean-going vessels. Just wondering whether are there also advancements, especially from QMINS, in the areas of new engine technology or retrofitting that can actually be applied for hovercraft?
Yes, thank you for the question. The first thing, as a large engine manufacturer, we see our ability to make an impact in decarbonization comes a lot in our installed base. So we have a very large number of engines operating around the world. And one of the first things we did, we announced it last year, is we announced the use of HVO and biofuels was approved to use in all our engines, right? So where these fuels are available today, our customers can immediately take big steps into decarbonization, right? And again, the installed base is very important to us. We cannot build enough ships to meet our greenhouse gas targets, right? Now, to answer your question, to us, the key bridge technology between now and when we go fully into electrification, we are working on dual fuel methanol engines, right? And so there's a couple of things why we're doing it. Number one is the work that we're doing right now. We have a couple of demonstrators, mostly in Europe, where we're working out the power density and the applications and a lot of this. But because we don't only service the marine market, we can also get economies of scale from technologies that are going to be broadly used in the future, right? So methanol is very important for us. The work that we're doing is what we call retrofit kits, right? That are going to be able to take our existing engines and then make them backwards compatible for dual fuel with methanol. So by doing this, we accomplish a couple of things, at least in our view. Is first, for any near-term projects, I think our customers don't have to wait for a technology to be ready. They can sort of future-proof, vessels and projects, knowing that we're bringing this technology forward. The second one is we can fail-safe disruptions in fuel availability, right? It's still not necessarily clear what supply chains will do in terms of fuel. And then finally, what we are working on, and this technology that we're bringing forward is going to be, like I said, backwards compatible into our larger installed base. But one of the things that we're working on is that a customer where the fuel is available could actually, within the maintenance life cycle of the engine, at a commercially viable cost, make their engine methanol dual fuel. So we have a couple of demonstrators. Hopefully there'll be news very soon.
Oh, that's great. Hopefully can get to see some of this.
In Singapore,
yeah.
yes. Thank you.
Thanks, Alex. All right. Of course, when we cycle back in terms of electrification, electric propulsion is actually one future-proof concept, right? And battery storage is not the only way to achieve electrification. There are also other ways, for example, fuel cell technology. So maybe over to Nikhil, just wondering, what are the key developments in fuel cell technology to support operations of larger hovercraft like tugboats or tankers with higher power demands?
Well, fuel cell is a proven technology. It has been there for many years. I mean, it was more common for land-based applications and for road applications. So when we started development of the world's first marine fuel cell from scratch, it took us 3 years. And there are a lot of technology advancements that were done to make it compatible to the maritime industry. So some of the key achievements, I would say, would be achieving a high power density, which is again very critical if we look at the tugboats, because for tugboats you need large power and there's always a space constraint. So for our solution, for example, like in a 20-foot container space, we can provide 3.2 megawatt of fuel cell. So that's pretty much solves the problem, and that's pretty much the power required for a tugboat. The other key technology advancement would be achieving a higher life cycle operating hours. So traditional fuel cells that are there for road application, normally the operating hours are 20,000. But we are able to achieve 35,000 because it's not feasible in maritime industry to replace fuel cells every 2-3 years. So 35,000 corresponds to 5 years, and there'll be a main overhaul after 5 years. The other key area is faster response to dynamic loads, which is again very critical for a tugboat operation point of view. You need very high power at a very short time. So the fuel cell, the PEM fuel cell, which we have, the response time is 3 to 5 seconds from 0 to 90% of the full load. So that in fact eliminates the use of a battery that would complement the fuel cell. So we have eliminated the battery use, making the fuel cell very responsive. And then in terms of safety, that's the utmost priority when you're developing something for the maritime industry. So we have worked very closely with the class. And what we have developed with this fuel cell is very different from the road application when it comes to safety. The fuel cell is gas safe. There's always a secondary barrier, making sure that there's no leakage of gas. There are a lot of EST protected in place. So if there's any leakage or any malfunctioning, there is systematic shutdown or emergency shutdown. We also have a big explosion relief valve on the back side of the fuel cell, which is not there on any of the fuel cell, for example, a road application fuel cell. So there's a lot of study, a lot of development that has gone in, and with this, all these technology advancements, I think the product, the fuel cell which is available today is ready to be installed in maritime, especially in hovercraft sector.
It's good to hear. Of course, then maybe over to Svein. We are looking at ammonia cracking to support the fuel cell site. So maybe tell us some any challenges or opportunities to actually adopt fuel cell technology for the hovercraft?
Yeah, it's a bit of a wide question, of course. Again, coming back to what we are developing in terms of using ammonia as a fuel source and generating hydrogen, thereafter then applying that hydrogen to a fuel cell, in our case, could potentially be, like a hydrogen internal combustion engine, something like that down the line. If we're talking about in terms of hovercraft, so the domestic fleet of Singapore, essentially, I would say some of the main challenges are the same that will also be applicable to the global merchant fleet. We have a new fuel type. We have a new technology. We have a new fuel supply, and we have new safety requirements that all come in under this. And at the end of the day, we also have new training requirements that will come with this as well. I think one of the next panels is focusing on a bit on the crew side, but that will be equally a important challenge or hurdle to overcome, both for the domestic fleet and also the international fleet. But likewise, all these items are also essentially opportunities because, of course, you have a problem or you have a challenge, and then it becomes a matter of, okay, how do you work your way through this? It's a new technology. It has inherent changes to risk or operational matters. Then we have classification societies to take care of that and ensure that the regulations are in place. We have various technology providers, fuel cell providers, engine providers, shipyards and ship owning groups that also play then the part in the whole sort of ecosystem of making this work. So I would say a lot of the challenges are transferable to also becoming equally an opportunity, to be honest.
Yep, cool. I mean, speaking of classification societies involvement, yeah, maybe to Shu Yong. So the various decarbonization pathways, the various alternative fuels, there's quite a fair bit of unknown in terms of how to manage them when we are trying to use them, right? So, and especially for some cases, we know, for example, methanol being a bit more flammable, or the ammonia being a bit more toxic. And for certain use cases, for example, like bunker tankers involving in bunker operations, this may pose some concerns, right? So just wondering from ABS standpoint, how is ABS assisting the hovercraft industry to mitigate such risks when delivering the marine services?
Thanks, Miro, for the question. I think basically from ABS standpoint, as during this energy transition period and of course alternative fuels, again, in the market, in understanding there's no silver bullets, but understanding from Singapore standpoint is this a multi-fuel hub. So from ABS point, basically, I would like to touch on 2 points, which just now Sivan has mentioned one thing, which is about regulations. So ABS actually come out a new development of the rules, which is part 1D in example, is to actually to look into alternative arrangement, novel the concept, and also new technology. Because as technology is always advancing as it goes along, the rules may not be able to catch up in time. So we actually come out this goal-based methodology in terms of our standards. So it actually means in the sense that the main classifications or critical elements of the engineering or rather the rules do not change. But we actually put in a certain concept which is called goals-based because we do not have that data or we do not have that industry good practice to actually tap on. So it actually becomes that we can actually categorize in different goals as tier, to achieve, to meet that requirement that the industry feel assured, or rather class as a safety net in a sense, feel is safe enough to operate in a sense. So that is where the goal-based methodology come in. And this goal-based methodology actually also developed in line with IMO Circular 1394, which is the guidelines itself of the goal-based standard and extensive experience with novel change, NTQ, new technology qualifications, and as well as risk-based technology. So with the help of this, it allows the engineer, sometimes, sorry to say, being an engineer myself, sometimes we can be just very siloed with regards to the regulations. But I think with this goals-based, it opens up the channel with discussion, working in collaborations with respective subject matter experts or even these OEMs like Sivan yourself, or Cummins, or rather also with the ship owners, depending on what kind of concept or rather operations they're looking at. Then we can actually look into the different rules. Looking at hovercraft, the hull, you may want to be light instead of the usual aluminum, all right, or the usual stainless steels or steel itself. So if you want to use different kind of materials, so what kind of industrial standard should we practice? So that's where the goal-based methodology comes in. Basically, there's like 5 tiers involvement with regards to role-based. So hopefully this can actually also help the industry in terms of new concept design and new technologies actually to move forward within ABS standpoint. On the second point is I would like to touch on is on technologies. So with the ABS, we also do with clients, or rather we have a simulation-based model, to actually helps in terms of decision making by doing simulations. So in the example, like Ping Wong just mentioned, if I have a bunker tanker that is maybe ferrying the cargoes as ammonia. So if I do a well to tank or I will do a ship to ship transfer, how would that be? What is the cloud dispersion going to be like? Ammonia in terms of maybe at 25 ppm, you can individual or the human can actually feel it or can smell it. But what is the critical level of it? How can we actually use a simulation base to make a decisions for emergency response plan? So I think that is part of the technologies that is involved to make that front-end engineering decisions on what kind of concept, what kind of safety process that is can be instilled followed by after that. So in terms of the design part or in terms of engineering. Yeah. So that's from an ABS point of view. Thank you.
Okay, thanks, Ruyong. Maybe I circle back to Tai Yong, just checking. Right. Under the Quad Maritime Group, Pax Ocean Group of Shipyards, they offer end-to-end engineering services, right? So, and supporting the whole complete life cycle management of maritime assets. So I think early on, Shuya mentioned about the whole goal-based kind of approach and methodology itself. Then, from Pax Ocean point of view, looking at the entire fleet, what are the proactive actions that Pax Ocean or Quad Maritime Group can take to support this decarbonization pathways?
Okay. Let me try to explain it this way. Pax Ocean as a shipyard group, we start from design of vessel. We build, and our sister company, Porsche, PCL, are also operators of conventional shipping and offshore shipping. Plus, of course, we do for third-party owners as well. And after that, we also have a facility in Batam that can do green recycling, which is certified by IMO. And we are able to issue the certificate for owners who wanted to do green recycling. And beside that, in our new shipyard in Singapore at Jalan Samalun, we are building it in using sustainability as a guiding pillar. So we aim to reduce the construction waste and also strive for the highest green mark level possible. For example, we want to use solar panel in all the buildings. We try to use the optimal or best energy saving HVAC system. Certain areas will be natural ventilated. We reduce the usage of HVAC. So these are some of the steps as a shipyard group we are trying to promote sustainability and go green. And in addition to that, our Center of Excellence for Engineering R&D will be located in the new yard so that to enable us to promote these new tech ventures and pilots to accelerate the development of their new products and services. And as a shipyard group, we also have a shipyard in Zhoushan as well. So we are working with international companies to go and look into upgrade and retrofit of vessel so that they can operate on green fuels like methanol and ammonia. We even, in our shipyard in Zhoushan, we even install rotosail. I think we are the first one in China who do that. Okay. So we are doing what we can as a shipyard group. Thank you.
Very nice to hear. And with all the proactiveness and things to do. There are some questions from the floor. One question that I think the audience have posed, and maybe I can also ask the panelists to talk about the first question. So, but expanding it a little bit, perhaps we could discuss a bit more in terms of the potential impact to decarbonize the hovercraft fleet, considering factors like infrastructure requirements and cost effectiveness. So maybe start with Alex, and then.
I think it's super important, right? Like I said, our engines could take many fuels today, but the infrastructure for those fuels is not available, or the sustainable supply of that fuel, the source, how that fuel is made, is it really green, right? And so that whole well to tank strategy is not completely highlighted there. I'm going to go a little bit of on a tangent, but I think what the work that MPA has done in terms of setting guidelines is fantastic. And if I could have a wish list, right, I would say work more with the ASEAN partners, right? Because I think a lot of the fuel strategies are going to be an ASEAN initiative. And obviously having that clarity on what fuels are going to be available where gives clarity to manufacturers like us, right, to work on the technologies to be ready and match the timelines of the infrastructure.
Anyone else would like to take a question?
Yeah, I can add more to what Alex said. So the challenge is basically especially for the Harbourcraft fleet, would be the cost of this green technology, because the cost of the green technology will be a very significant portion of the entire cost of the Harbourcraft. So that is something we need to work together. I mean, of course, as a fuel cell manufacturer, if we get the demand, then only it's all about economies of scale. So that is one thing. And when it comes to the operations side, the availability of, for example, hydrogen, that's again a challenge. And even if it's available, the cost of hydrogen. So today, probably in Singapore, the cost is 2 to 3 times of green hydrogen. So that is again a challenge that need to be addressed. Also, in terms of infrastructure, the bunkering frequency, the storage of hydrogen on the Harbourcraft, that's a challenge. So to give you an example, if for a 1 megawatt fuel cell capacity, and if the tugboat operates for about 10 hours a day, it would need easily about 500 kgs of hydrogen. So which is equivalent to a 20-foot container that can store up to 480 kgs of hydrogen. So we need to refuel it every day. So that's again a challenge, I would say.
If I may add on, it's quite heartening to see just now MPF is driving the electrical charging facilities and infrastructure in Singapore. I think potential impact on this electrification for Harbourcraft, beside the cost, I think important thing is we should promote the use of the craft. Currently in Singapore, I think there's more than 1,600 lighter craft. So if we can promote the use of a electric supply boat that can carry more, for example, the load of 4 lighter craft today, we can effectively reduce the number of craft piling in Singapore coastal water. This will lead to less emission and also safety of the marine traffic around the coastal water in Singapore. So I think this is also will be a very good impact, improve the efficiency. Moreover, I understand that currently, sometimes the waiting time to load a lighter craft in, for example, Jurong Port, it takes a long time because you come alongside for maybe you need 15 to 20 minutes to come alongside. Yeah, you load 1 pallet, 2 pallet, and then there's a long queue, bottleneck. But if you have a bigger vessel, you come alongside for 10, 15 minutes, and you can load 60 pallets or even 50. Then the efficiency will go up. And I think by promoting the use, we can actually offset some of the higher costs required to get this electric craft. Thank you.
Yeah, I'd just like to add on as well, because I always think this is a interesting conundrum for, especially for Singapore, when if we're talking about the infrastructure to charge vessels, because these vessels, they go many places, of course. So you'll need to set up the correct charging infrastructure where these vessels actually are. I mean, today now, there's the setup at Marina South Pier, as Kester showed here in their opening remarks, some of the hot swapping is currently taking place by essentially trucking the batteries to a hot swap location and then back again. So one of the potentials that's sort of we're trying to look a bit into is essentially a off-grid solution. Today now, a lot of the infrastructure is tied up obviously to where the power grid actually is. You're going to charge your vessel or you're going to charge your battery, you need a grid connection. But if we look at a solution where we utilize, for example, then fuel cells, we can have ammonia being the fuel, that can go into a AMG system or a cracking system, generate the hydrogen, which then generates the electricity through the fuel cell. This can essentially then be a off-grid solution that can be where the vessels are. For example, in where the ammonia terminals will be in the future, or wherever else you can go to actually refill the ammonia. So this is always a, yeah, it's a relevant concept for Singapore especially, but also for any other location, so to say.
Thanks, panelists. Hopefully that sort of addresses a question from the floor. We discussed quite a fair bit in terms of the various technology, and of course, everything being new itself, there's always this also other concern on having the right and necessary competency. Yeah. Not just in terms of the design aspect, but of course, subsequently, we are looking at it from during the operation, during the maintenance, even to the surveying side of it. So maybe can I ask question to Shu Yong, and then maybe if the rest of panelists would like to chip in as well. What do you all think? What are the things that actually needs to be done or can be done to actually support all this? Yeah.
Thanks, Pirong. I think it's a good and relevant question. I think everybody is always asking these questions. I guess I think I always remember. I think initially the electrification started. In terms of MPA EOI. I think Mr. Kenneth Lim also do mention this phrase, all hands on deck. Which everybody has to come together, working together. I think from class perspective, is always looking into collaboration and partnership with all the stakeholders within the value chain as well. So I think that's where the learning curve comes in, not only within the classifications, but also with some of the subject matter experts within the industry as well. Of course, a lot of partners always depend on class to see what is the regulations involved. Where do we stand? How do we see it? But I can always be very truthful to you, being a surveyor myself last time. I can always say I do not have the golden answer as well. But it's always a takeaway to actually collaborate, come back, discuss, and look into details of the aspect of the process, the procedures, and how can it be improved thereafter, in terms of that particular. But again, like what I mentioned, I think with the moving forward of the technologies, advancements, the methodology that ABS is coming with the goal base is actually looking into as well as the functional requirements. So not only within the class systematics itself, but how does the products functions? How does the in the sense of the fuel also function as well in terms of chemistry, and what is the safety involvement? How can we actually mitigate the risk in terms of the assessment as well? And looking at that, of course, after the function requirement, where we look into the engineering, the design, then we'll also look into the verification and conformity, working together hand in hand, even with like the engine maker yourself, because you know better, because it's your design. How can it actually verify and confirm that this using of this fuel, you actually cut down your emissions? How can you validate the emissions at the end of the day? And that's where the regulations and the class comes in as an industry to input, to suit to the industry needs. And that's where we also try to cater for the best industry practice as a whole, and also looking into how does the vessel operates, working very closely with the ship owners, in terms of the advisory part, in moving forward as well. So I think this is a very holistic kind of collaboration and partnership within the stakeholders itself. I think that's where the people also get trained when doing all these projects together as well. I think that's hand in hand. Yeah.
I think besides that, I would like to add on that the Corp Maritime Group, we are going to invest and build Harbour supply craft. I think the important, besides meeting all the regulations and class requirement, it's also important that we hear from the operators of the vessel, so that we know exactly what is needed during operations. At the same time, the designers must be also very mindful that since it's a small vessel, it must be designed for production. For example, and also maintenance, for example, because the batteries are very heavy. How are we going to install and remove the batteries? Being a very small vessel, the welding quality and the way of doing it is also very challenging. So some of these things, on the practical side of it, I think it's important that the CSA work together and develop something that is meet requirement and yet easy for production and maintenance. Thanks.
Thanks. Yanni?
Yeah, I'd just like to add that, you can see that technology is fragmenting from, just fossil fuels into different options. And one of the things that we think a lot about is how many different touch points you're going to have for these different technologies. And so the human factor is going to be super important in terms of having people that are trained, capable. They're going to be, there's some materials that are toxic, some that are high voltage, right? So you're going to have a multitude of technologies. And I think one of the challenges we need to face is we're going to have technicians and people touching these products on a daily basis. And it's going to, it's going to be harder to have somebody that is only specialized for one particular technology, and keep that workforce, fully trained.
Thanks, panelists. I'm mindful of time, and then there's still one more panel to go. Perhaps more for closing, just one last question to all the panelists. I mean, there's quite a fair bit of things that we have been doing, and there's still quite a fair bit of things we need to do. So in your opinion, what more can be done to actually accelerate the development and deployment of such technological solutions, especially for the larger hovercraft types? Perhaps we start with Svein first, and then moving back.
Yeah, I mean, we had the Secretary General of IMO here on Monday saying IMO is not slow. But at the same time, I think for a lot of the new technologies, the new type of fuels that are coming out, again, both for the global merchant fleet, but definitely just as relevant for the Harbourcraft of Singapore as well. I would like to see sort of a bit of a focus on, let's say, there's a saying of slow is steady, steady is fast. And I think that is something that we should keep in mind on this, and have as many partners as possible come around the same table to bring this forwards. I think for any alternative fuel today or any alternative propulsion method, there's not really any competitors in this. Everyone has the same end goal.
Thanks, Mike. Sure.
Yeah, I guess everyone, I think we have to be aligned in the sense of the objective by 2030, 2040, or even 2050. Likewise, I've mentioned is collaborations and partnerships. And of course, I think one thing is looking at the cost as well. To how be more cost effective. How can we encourage more companies to be the first mover, to try out in these energy transitions and also alternative fuels period. I guess that is where the industry has to come together. And of course, the financial institution also has to be very helpful to the market in terms of that as well. And of course, like Taeyong has mentioned, they take the initiative to be the first mover to drive. I think this is one very good point to see in Singapore that hopefully can actually encourage back to other countries as well. Yeah.
This morning, banner, I think somebody mentioned that all this initiative it'll be good to back by the government because the government are rich. I think in Singapore, MPA has been very actively engaging the industry, and we would like to look forward to have more targeted workshop in the future as a support to the maritime industry. Just a personal opinion, example, maybe MPA can provide us some clarity on the carbon tax for maritime, so that our industry can be more prepared for the future. The other thing is, electric vessel is higher cost compared to conventional vessel. I think we may need some regulations in the future, maybe in phases, so that we level the playing field. And it will be beneficial for the industry, so that this incentive can motivate the adoption of green vessel in our coastal water. Thank you.
I think creating a strong ecosystem, having multi-stakeholder synergies, and MPA is already very active on this front. So I think there has to be a strong synergy between the green molecule supplier, between the operator and the end customer, as well as the technology provider, so that each party is able to get long-term contracts, and that's how we'll be able to bring the costs down. So this is on the operation side. There's a lot of synergies, collaboration that needs to be established. Then also to establish a level playing field, there has to be some incentives that can come from the government for these early adopters of green technology. Thank you.
Well, there's not a lot more to say. They've really done a really good job, my fellow panelists. Again, you know, the collaboration with MPA and the industry and the guidelines and the visibility is fantastic. I think I said it earlier, looking at something more regional, right, and not just efforts in Singapore, and I think everybody would benefit. We heard about the cost of the technologies, and if we have more economies of scale, you know, we can make them faster and cheaper sooner.
Okay, thank you, panelists. Yeah, I agree. Quite a fair bit of the collaboration efforts is important, and not just from the technologies, the shipyard, the engine makers, classification societies, but also bringing in operators, maybe even the users themselves, to really understand that decarbonization is actually something that everybody actually has to work together towards that. Right. So I think with that, we come to the closing of this panel.
Thank you.
Thank you very much.
Thank you.
Thank you.
Thank you.
A huge thank you to Mr. Ng and all our panelists for the great discussion. Could we take a group photo before you take your leave, please? If you could just move to the front. Thank you once again. May I kindly invite you to return to your seats. Thank you.